Bernoulli equations. A differential equation, a first order ordinary differential equation in this form, dy over dx plus pxy. Look at here, y prime. This is function of this independent variable x equals qx times y to the n, is called a Bernoulli equation. Okay. Then this is not a linear unless n is 0 and 1. It's a non-linear in general. Then we don't know how to solve. But this is a special type of non-linear, and by a suitable substitution we will be able to solve this. Okay, so when n equals 1, the case, let's say n equals 0, y raised to 0, then this becomes a linear. So dy over dx plus pxy equals qx times y raised to 0, which is 1. Now this is a linear first order differential equation, and to solve this we just find an integrating factor and we solve. Okay, it's done, linear. And when n is 1, what do we get here? Now dy over dx plus pxy equals qx y raised to 1. Now if we bring this to the left side, subtract qxy from both sides, then we can make it a linear. The right hand side will be 0. Or if we move this over and factor y, then we can make it separable. So this is both linear and separable. Then like this, dy over dx, move this to the left, then we can factor y out. That leaves px minus qx. Okay, now this is a linear. We can think in this way, y prime function of x. Or we can move this over and separate the variables. When we move over, subtract, then we can factor y qx minus px. Now is the product, so we can move dx to the other side, y to the left side, separable. So when n equals 1, this is both separable as well as an linear ODE, and we already know how to solve these types. Okay, now the issue here is when n is not equal to 0 and not 1, then how to solve this? Now we want to solve, let's say, star when n is not 0, not 1. Okay, so this is non-linear in this case, not separable obviously. Now we can make a nice substitution. That's one smart substitution which was done by Bernoulli. Then we are able to reduce this into a linear. With that substitution, this reduces to a linear ODE, and we know how to solve. Once we have a linear, we find the integrating factor. Okay, so here is the thing. So what we do is divide both sides by y raised to n. Okay, star can be written as divide by y raised to n, so 1 over y raised to n dy over dx plus what we have in the middle, px y, we are dividing by y to the n, so this will be px y over y to the n, so y raised to 1 minus n equals qx. Okay, and looking at this, we can see that this one is not a nice function. So if we say this equals some function, let's say v, if we denote this by v, then we might be able to reduce this into a linear. Okay, that's the thing we do here. So we let v be y raised to 1 minus n. Okay, now we have dy over dx. So pretty much we are trying to convert this in terms of v and x. So we need to find dy over dx now. Okay, let's find the derivative of both sides with respect to x. So dv over dx will be 1 minus n y raised to 1 minus n minus 1. So minus n times, from the chain rule, dy over dx. That means dy over dx is this divided by this. So dy over dx is equal to, so dy over dx is, move this over, so 1 over 1 minus n, y to the negative 1 on the bottom means y to the n on the top, dv over dx. Now let's go back and plug in here. Okay, so we got 1 over y to the n times dy over dx is here, 1 over 1 minus n y to the n dv over dx plus px, that's v, equals gx. Now we can simplify y and cancel. So 1 over 1 minus n, let's multiply through by 1 minus n, then let's cancel. We have dv over dx plus 1 minus n px v equals 1 minus n gx. Now this is linear. Okay, this is a function of x, and v dv over dx is a function of x. So linear in v. So we used to have linear in y, but it's linear in v. Then to solve this, we find an integrating factor. Integrating factor mu x is then, so for like px we got this. Okay, so integrating factor is then e raised to 1 minus n, it will be a number. Okay, 1 minus n is a number, px dx, and we just integrate, and that's exponential, that's integrating factor, and we multiply both sides of this differential equation by this integrating factor. Then multiplying this 3 by integrating factor, the left hand side always becomes derivative of dependent variable v and integrating factor. I'm just writing this, equals, right hand side we multiply this 1 minus n gx by this integrating factor. Now we integrate both sides. Okay, integrate with respect to x. Then we have v times mu x equals antiderivative of this. Then divide by mu x, so our v is back, but v is not the variable we want to find. Now we need to back substitute v, and v is given by y raised to 1 minus n. So n is a number, so it will be y something. Then we have y raised to something, that equals here. Okay, solve and back substitute v. Back substitute v. V is in fact y raised to 1 minus n. Okay, this is how we solve Bernoulli equations.